You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome back. I spent part of last week trying to update this tiny little internal tool I built.
Oh, yeah.
And I swear, I opened the terminal, typed one command, and my computer just started yelling at me.
Right.
3 major framework changes, 2 breaking dependency updates, all in the 48 hours since I last looked at it. The speed of change right now is just, it's breathtaking.
It's more than just speed, though. It's acceleration.
Yeah.
The ground isn't just shifting. It feels like it's being completely rebuilt from the foundations up.
And the force driving all of this, of course, is AI, these sophisticated autonomous tools.
Exactly.
So that's really what we have to unpack today. This isn't just about, small improvements for developers anymore. We are looking at a complete architectural overhaul.
It's a total shift.
Yeah.
We're moving from a world where humans write features to one where humans define systems. The whole game is changing from execution to orchestration.
Okay, so let's jump right into what I think is the most stunning piece of news here. The breakthrough in actually scaling these autonomous agents. For the last year or so, they've been good, but
Yeah.
very limited, right? You give them one well-defined task, they're great.
They crush it.
But if you ask a group of them to work together on a big, long-running project,
Right.
they'd fail. They got bogged down, risk-averse.
That's the classic coordination bottleneck.
Yeah.
Think of it like a giant scrum meeting where nobody can do anything until everyone else agrees. It doesn't scale.
But the Cursor team solved this. And they used a surprisingly simple, almost traditional pattern, the planners and workers model.
It sounds so mundane, but the impact is massive.
So explain that. The planner agents, they're the ones that take the big goal and break it down into smaller pieces.
Exactly. They break it into these discrete executable tasks, and then the worker agents, they just execute them.
Independently.
Completely independently. They have zero concern for what the other workers are doing. The genius is in the isolation.
No more waiting for approvals.
None. And this fundamental change allowed them to run hundreds of agents at the same time for weeks. The result, they generated over 1 million lines of code.
1 million lines of code. That's just staggering. And they weren't building small things. We're talking large-scale code migrations and get this building an entire web browser from scratch.
The scale is the story. And it leads directly to this new philosophy that's taking over. The idea that code is cheap now.
Right. If you can generate it that easily, the value of just writing it has to drop.
It plummets. Tools like Claude Code are already driving the cost of small projects down towards zero.
So this changes the whole economic model. If code is cheap, you don't obsess over standardization in the same way. You can move toward, what was the phrase? Bespoke artisanal software?
Exactly. Think about it. Something like 50% of engineers spend their time building internal tools.
Yeah.
Dashboards, reports, that kind of thing.
Sure.
Why force them all onto one generic platform when an agent can spin up a perfectly customized tool for their team's exact workflow in like an afternoon?
The scarcity is no longer the labor to write the code. It's the labor to define what you want and then check if it actually works.
You've got it. The human role shifts from mechanic to architect.
Okay, so that makes sense at the high level, but let's get into the weeds. What are these agents actually using to get this done? My first thought is that 1 million lines of code requires some hyper-complex AI-optimized environment.
And that's the counterintuitive twist here, which I just love. The big realization is that simple foundational tools are often way better for these agents. The material we looked at basically says bash H is all you need.
Seriously, just the basic bash H shell, Unix commands. How does that beat a custom vector database?
It's all about context and retrieval. So Vercel found this with their internal agent, D0O. They made it much better by simplifying it to just use basic bash H commands, a standard file system. It gives you a natural data hierarchy that the LLM already understands.
So instead of a fuzzy search in a huge vector database, which can be imprecise,
Right.
the agent can just run else or grep or cat on a file system that's already logically structured. It gets an exact match.
Precisely. And that overcomes the whole prompt stuffing problem. You minimize the context the LLM needs to load because retrieval is exact. The agent knows exactly where to look.
That's brilliant. But hang on. If we're giving agents BAH access to a file system, aren't we just opening up all the security holes we're trying to avoid?
That is the tightrope. That is the essential security question, and it brings us to guardrails. You absolutely cannot trust the agent's output or its actions by default.
Which is where tools that constrain what the AI can actually generate become critical, especially for the front end.
For sure. Let's say an AI generates a new dashboard component.
Yeah.
How do you stop it from creating something malicious or just broken?
You have to force it to speak a language you can validate.
Exactly. And that's where libraries like JSON Render come in. It lets the AI generate UI, but with one massive constraint. You, the developer, have to first define a catalog of allowed components and actions.
So instead of spitting out raw HTML or JavaScript, which is a nightmare to audit, the AI just generates a schema-validated JSON object.
The JSON object that just points to the pre-vetted components you already approved.
The human builds the safe sandbox, and the AI just plays inside it.
That's it. It keeps the output predictable and secure.
Okay, speaking of complexity, as these things scale, the number of tools an agent could possibly use must just explode. How do you keep the agent from getting overwhelmed?
It's a real problem. The technical term is tool sprawl, and it just eats up your context space. Claude Code is trying to solve this with a feature called tool search.
For their internal system, the M50 protocol, what is that exactly for our listeners?
You can think of the MCP protocol as the API the agent uses to talk to its own tools. It's how it knows what it can do.
Okay.
Before, it had to load the description of every single tool it might ever use into its context memory at the start.
That sounds incredibly inefficient.
It is. So with tool search, it dynamically loads the tool descriptions via search only when that tool is actually relevant. It saves a ton of context space and just makes the whole process faster.
So we have layers of security, constraint on the architecture with Bashik, constraint on the output with JSON render, constraint on the context with tool search. But let's go back to the biggest risk. Giving code access to internal environments. You mentioned a critical vulnerability.
Yes. This is crucial for anyone adopting these tools. The material points out that Claude Code, which is the interface for non-devs, is susceptible to file exfiltration.
How?
Through indirect prompt injection. An attacker can basically trick the agent into sending files to the attacker's own server.
Whoa, that's a huge breach risk. So what's a professional-grade solution here?
You have to separate your secrets from the sandbox entirely. The best practice is using a network proxy. The proxy intercepts the agent's network calls and injects the real API keys outside of the sandbox environment.
So the sensitive data, the environment variables, and keys are never actually exposed to the Claude Code environment itself.
Exactly. It's more engineering work, but for security, it is absolutely non-negotiable.
Okay, security handled. Let's pivot now to the really practical takeaways for the human developers out there. And we have to talk about React. For years, there's been one universal source of pain.
Yes. The dependency array wars. The source of infinite loops and stale closures.
And thousands of hours of debugging. Managing the dependency array in UseEffect was. It was just this messy, brittle workaround using useref.
It was a necessary evil, but it really made writing clean React code difficult.
Well, finally, React has introduced the UseEffect event hook. And this is a massive win.
It's the breakthrough we needed.
It's a clean, built-in way to get current state values inside an effect without having them trigger a rerun every time they change.
It cleanly separates the logic that is reactive, the things that should cause a re-render, from the logic that's just event handling. This one change is going to prevent so many bugs.
That's a real quality of life win. And it kind of speaks to the value of pre-packaged expert knowledge, which is something Vercel is doing with its agent skills repository.
Yeah, if agents are going to write code, they need to write good code. Vercel's agent skills is basically a library of instructions for the AI. For instance, the React Best Practices skill has over 40 rules for optimizing React and Next.js performance.
So instead of trying to train the base model and all this stuff, which is expensive and gets diluted, you just load the expert skill when you need it.
It's like giving your agent a decade of performance engineering experience instantly.
And that leads to a really interesting architectural choice from the Tangle team. They built their own documentation site, but they weren't fighting performance, they were fighting complexity.
The requirements were fascinating. They wanted no JavaScript, low complexity, and easy styling.
Which is a real counterpoint to the huge, complex frameworks we see everywhere. How'd they do it?
They used Pandoc to convert a single markdown file to a static site. But the clever part was how they handled interactivity, like a collapsible sidebar, without any JavaScript.
Ow!
They used the new Popover API. It's a platform feature that lets you build things like menus with pure HTML and CSS, no JS required.
And for search.
Even simpler. Instead of some complex search index, they just provide a single-page version of the whole site. So you can just use your browser's native keytrol plus F search. It's the ultimate low-tech efficiency.
It's amazing. And speaking of foundational efficient tech, we've talked about all these complex agents and AI, But none of it happens without the quiet king, Markdown.
It's incredible how essential it became. John Gruber created it back in 2004, and today it is the lingua franca for everything from Git repos to the instructions we feed these AI agents.
And the really wild part is that despite its immense value, he never monetized it. It just won because it was useful.
It's a true legacy. Which brings us to the business environment and what all this means for your career. If code is cheap, where is the economic friction now?
One place is definitely the observability space. There's this willful ignorance among vendors about data waste.
Right.
Clients are paying escalating costs, but an average of 40% of the observability data they store is completely unused.
The whole system forces the client to be the cost police.
Yeah.
The business model incentivizes storing more data, not better data.
That waste also affects internal teams, especially with internal developer platforms or IDPs.
Absolutely. IDP roadmaps accumulate debt by just borrowing industry trends without validating them. They build features because they're cool, not because they're needed.
So what's the solution for those teams?
You have to treat every roadmap item as a testable hypothesis. Don't build something because it's a trend. Build it to test if it solves a real, measurable internal problem.
That focus on essential value is also driving how the big players are defending their markets, right?
Yeah.
How are they reacting to AI competition?
They're restricting API access. Big incumbents like Salesforce, Datadog, Epic, they're starting to throttle their public APIs to defend their data modes.
Slack is doing it too, right? Limiting calls to 1 per minute.
Yeah, it's a clear signal. They see these AI tools that ingest massive amounts of data as an existential threat.
So let's talk about the career path. With all this change and even layoffs, what does success look like beyond being a senior engineer?
The staff engineer role is becoming strategically vital. This is that beyond terminal level. You shift your scope from writing features on one team to solving big problems across multiple teams.
Or becoming a deep technical specialist. The archetypes are like the tech lead, the architect, the solver.
Right, and you get there not just by time served, but by leading projects that have a huge direct business impact.
And what about the other end? The junior developers. If code is cheap, why hire them?
It's the junior developer paradox. Despite layoffs, you need them. They're the ones who build new institutional knowledge. And crucially, they're the most eager to adopt and accelerate all this new AI tooling inside a company.
So they bring the fresh energy while the staff engineers set the direction. This has been a really thorough look at the landscape. It feels like this is the kind of shift we love to track here on the Vocal Technologist.
It really is.
We've covered scalable agents with planners and workers, the architectural guardrails like JSON render, huge platform wins like use-effect event, and how the whole business is adapting.
And you remember we talked about the Cursor CEO using hundreds of agents to build that web browser in a week. 1 million lines of code.
A monumental achievement in code generation, for sure.
But here's the detail for you to really think about. The resulting software, it only kind of works. It is nowhere near production ready. The system generated the code, but it did not generate the software.
Right.
So if AI can now generate 1 million lines of code cheaply and quickly, but the code still needs a human engineer to make it robust, secure, and maintainable, what's the real skill we should all be focused on developing right now? What's the thing that can't be commodified? Is it debugging? Integration? Or is it just getting better at defining the problem in the first place? That's the question to mull over.
Spoken Tech for your ears.